Hi guys, today we're going to talk about 7.4 quadrilateral notes. Our I can statement: I can understand that the sum of any quadrilateral is 360 degrees. I can find missing angle measures in quadrilaterals, and I can construct quadrilaterals. All right, so let's talk about some of the terms. One more term that we have to add to this chapter is quadrilateral. A quadrilateral is a polygon with 4 sides. So below, we're going to actually take a look at kind of a chart, and you have a little bit of writing to do on this one. On the video part that I'm showing you, it's all filled in. So go ahead and you can either pause the video and fill it in, but make sure you do listen to the rest of it. I'm going to go through each of them. So a quadrilateral is any 4-sided figure or polygon that has 4 sides. A trapezoid, we're going to break that quadrilateral down into 3 different types. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. So that is actually talking about the top and bottom. They are being identified by a symbol that identifies that they are parallel to each other. If we look at parallelogram, a parallelogram is a quadrilateral with opposite sides that are parallel and congruent. So parallel is going to be, again, these 2 symbols. Okay, and because the one on the left and the right, they have 1 that identifies that those 2 are parallel, and the top and the bottom, they have 2 of those symbols that is identifying that those 2 are parallel. Then we have, let's try a different one, the symbols that identify that these are congruent. Congruent, remember, means the same. So the top and the bottom, those lines are going to be the same. They are the same value. The left and the right are also going to be the same value. Okay, let's look at kite. Kite is a quadrilateral with 2 pairs of congruent adjacent sides and opposite sides that are not congruent. So when we look at this, we have the same sides, or quadrilateral with 2 pairs of congruent adjacent sides. Remember, adjacent means that they're going to share that line or that vertex. So these 2 are going to be right next to each other, and they share that in common. And then you have your other set that have that vertex in common as well, and they are not opposite sides that are congruent this time. So they're not opposite to be congruent. They are going to be those just adjacent sides that are congruent. Okay, so let's go on back to parallelogram. Parallelogram from this point is actually broken up into 3 other types of shapes. We can talk about a rectangle. So a rectangle is just a parallelogram with 4 right angles. So we do have 2 sets of congruent sides. So we have one set and the other set. Okay, let's jump over to rhombus. A rhombus is a parallelogram with 4 congruent sides. So we have 4 sides that are going to be exactly the same. It doesn't say anything about a right angle in this one. So in a rhombus, there are no right angles that we have to worry about. But both of these can drop down to be a square, okay, or pointing to the square. So here we have a parallelogram with 4 congruent sides and 4 right angles. So the square actually has the most specifications that any of the different quadrilaterals would have. So a square has the 4 right angles, and a square has to have all 4 congruent sides. Okay. All right, so let's take a look at example 1. We have to classify this quadrilateral. So when we look at this quadrilateral, we have 4 right angles and we have 4 congruent sides. So this one would end up being a square. Let's get rid of that. Okay, let's look at B. We have 2 pairs of congruent sides that are adjacent to each other that are not opposite. So we have this and this being adjacent, and we have this and this being adjacent, and those are both sets that are congruent to each other. So that would be identified as a kite. All right, go ahead and pause the video and try the next 3 on your own. All right, so let's take a look at some of the angle measures of a quadrilateral. So when we talk about triangles, triangles are 3-sided, they equal 180 degrees. But when we're talking about quadrilaterals that have 4 sides, we are actually going to have a total of 360 degrees. And I am going to go back and explain why. So when we go up here, a square is the easiest to look at, I think. So we have 4 right angles in a square. So each right angle equals 90 degrees. So if I have 90 degrees there, 90 degrees there, 90 degrees, and 90 degrees, when I add 9 plus 90, 90 plus 90 plus 90 plus 90, that's going to give me my 360 degrees. And that will work for every type of shape that you have for quadrilateral. So any sum of any quadrilateral is going to equal 360 degrees. So if we take a look at example 2, we are going to have to figure out what our unknown value of x is. So we know that if I have the 115 plus my x plus my 75 plus my 70, the total has to equal 360 degrees. So I'm going to add those together. So I have 115 plus 70 plus 75 plus x. That has to be set equal to 360 degrees. So when I combine all those terms, that actually gives me 260 degrees plus my x value, and I'm still going to set that equal to 360. From here, I want to get the x all by itself, just like solving a one-step equation like we've done for months. We're going to subtract, and that leaves me with x equals 100 degrees. All right, go ahead and pause the video. You have 2 try on your owns, 4 and 5, that I'd like you to do. And you are going to have to look for the second set of 7.4 notes for example 3 and for the try on your own number 6, using a protractor to construct a quadrilateral.